Okay, so the first molecule I'm going to make is xenon tetrafluoride, which is SeF4. Okay, two counting valence electron, Se have a electron, plus fluorine have 7 electron times 4. So we have total of 36 electron. Then I'm going to draw the Lewis dot structure. So Se have the least electron negativity, so it's going to be in the middle, and then it's surrounded by 4 fluorine. And then I'm going to put the electron around the fluorine. And we need 4 more electrons, so I'm going to put it on the central atom. So we have total of 36 electrons. This is the octahedral electron domain geometry, and this specific molecule is a square planar. The shape of this molecule is square planar, and I make this molecule from gums and what is it? From gum and this stick is a okay, so the central atom, the green gum is Se, and this 4 white gum are fluorine, and then the 2 yellow gum opposite right here is the 2 lone pair. The bond between the adjacent atom is 90 degree, and the bond the angle between the 2 lone pair is 180 degrees. And the central atom hybridization is sp3d2. Okay, so now I'm going to redraw the Lewis dot structure in 3D version to see how it looks in 3D version. So I'm going to have Xe, and this here is fluorine. This is fluorine. So we can see the 2 fluorine going in the front, so that's why I make it look darker, and this one also, and this one coming, so I can like in the back, so that's why I make this one is the dot unconnected line. And so we're going to put the 2 lone pairs, so right here. And the bond between these 2 is 90 degree. This is polar covalent bonds, polar covalent bond, but the overall polarity of this molecule is non-polar. The formal charge for each atom is going to be 0. Okay, and so I'm going to draw the delta notation for this molecule. The Se have less, so fluorine have the most electron negativity, so it's going to have like negative delta notation, and Se have positive delta notation. And I'm going to draw the same for 4 bond right here. Okay. The second molecule I'm going to make is phosphate ion, which is PO4 3 minus. To counting the valence electron, I have 5 on P plus 6 on oxygen times 4, and then there's a negative 3, so we have to plus 3 more electrons, so total is going to be 32 electrons. Okay, I'm going to draw Lewis dot structure for this. The P had less electronegativity, so it's going to be the central atom, so it's going to be surrounded by O. Okay, I'm going to put all the electron on the oxygen atoms. So we already have total of 32 electron. And for the formal charge, it's going to be a negative on the oxygen, and it's all the same, so negative on all 4 oxygen. And then on the phosphorus, it's going to be positive. It's at positive 1 charge. And so the overall charge for this molecule is -3, so it makes sense. Next, I make this molecule from noodle stick and the gum drum. So the central atom right here is the black one right here is going to be the phosphorus, and the 4 white drum right here are the oxygen. And so this have tetrahedral electron domain geometry, and for this specific molecule is also tetrahedral shape, and the bond angle between the adjacent atom is 109.5 degrees, and the hybridization of the central atom is going to be sp3. So I'm going to redraw the molecule in the 3D version. So I'm going to put P in the middle, and then O, and then going backward, there's 1 more O atom, and because the phosphorus had the less electron negativities than the oxygen, so it's going to have the plus delta notation on phosphorus, and then on the oxygen is going to have the minus delta notation. And this bonds right here is covalently bond, polar covalent bond, but the overall polarity for this molecule is going to be non-polar because all of these going to be canceled out. So, and it looks symmetrical on all sides. The next molecule I'm going to make is going to be chlorine trifluoride, which is ClF3. To count the valence electron, the chlorine have 7 valence electron, plus fluorine also have 7 electron with, and times 3, which is 7 times 4, 28 electron. And I'm going to draw the Lewis dot structure because Cl have less electron negativity, so it's going to be the central atom. It will be surrounded by fluorine. I'm going to put all the electron to surround the fluorine atoms. And right here we only have 8 times 3, 24 atoms, and we need 4 more, so we want to put it on the central atom. Okay, so I finished drawing the Lewis dot structure, and I make this. I already make this, and the central atom is chlorine, and it's surrounded by the 3 fluorine. And then this one, the 2 yellow one right here, are going to be our lone pair. And so this this has the trigonal bipyramidal. Oh, I don't know how to say it. Trigonal bipyramidal. That's right. Electron domain geometry, and for this specific molecule, the shape is going to be the T shape, and it's the central atom hybridization is going to be sp3d, and the bond angle between the adjacent atom is going to be 90 degrees. I'm going to redraw the Lewis dot structure in 3D version. So it's going to be Cl, F, fluorine, and fluorine. And this one pair of lone pair going to be backward, and one pair is going to be forward, so I will make it a thicker line. And there you go, we have the molecule in 3D shape. And I'm going to draw the delta notation for this molecule because the fluorine have the most electron negativity, so it's going to have the negative delta notation. And chlorine going to have the plus delta notation. And the bond between the chlorine and the fluorine is going to be polar. Is polar covalent bond. And the overall polarity of this atom is going to be polar because it's unsymmetrical based on the shape, so it's going to be polar molecule. Like the polarities of this, the overall polarity is going to be polar. And I'm going to state the formula chart for the chlorine, and the fluorine is going to be 0. The next molecule I'm going to make is beryllium hydride, which is BeH2. To count the valence electron, H have 1 times 2 plus Be have 2 electron, so it's going to be 2 plus 2 is 4 electron total. And I'm going to draw the Lewis dot structure for this molecule. The Be going to be in the middle, and then H, and then H. And because H only can have 2 electron, and so this is the good Lewis dot structure for BeH2. I make this one. I make this one, and this is the central atom. This is the central atom, beryllium, and the 2 white one is hydrogen, and this is the shape of it. And the bond angle between the adjacent atom is going to be 180 degrees. It's going to be a straight line. This one has linear electron domain geometry, and this shape specifically also a linear. The hybridization of this molecule is going to be HP, and the bond between barium and hydrogen is going to be ionic, polar ionic. This one's going to be a polar bond, but the overall polarity of this atom is going to be non-polar because it's all cancelled out. I'm going to redraw this Lewis dot structure in 3D version, and it's going to be the same. H, and I'm going to say the the delta notation, because H going to have negative delta notation. The formula charge for each atom on this molecule is going to be 0. Okay, so the last molecule I'm going to make is going to be carbonate ion, which is CO3 2 minus. To count the valence electron, carbon has 4 electron plus oxygen has 6 times 3, and there's a 2 minus, so we're gonna plug 2 more electrons, so we have a total of 24 electrons. Okay, so I'm going to draw the Lewis dot structure for this molecule, because C has the less electron negativity, so it's going to be the central atom, and it will be surrounded by 3 oxygen atoms. Okay, so I surrounded all the oxygen by the electron, but we can see right here, carbon only have 6. We have total 24 electrons. We have already 24 electrons, but carbon only have 6 electrons, so it's not in the octet, which is have in the octet. So we need to make one of these bonds become a double bond, so it could be in an octet shape. So I will make this one a double bond, and so I'm going to erase this pair of electrons, so we still have 24 electrons, and C, the central atom, also have 8 electrons surrounded. I make this one, so this central atom right here, the black one is going to be carbon. This 3 white one are the oxygen, and right here I also make the double bond, so it's thicker, like it's double. There's two noodle stick right here, and only one on these and these. Okay, and so this molecule have trigonal planar electron domain geometry, and for this specific molecule it also have the shape of a trigonal planar, and the bond angle between the adjacent atom is going to be 120 degrees. And the hybridization of the central atom is going to be sp2. Okay, I'm going to redraw the Lewis-John structure in 3D. So C, double bond, O. And so for the formula chart, for this oxygen right here is 6 minus 1, 2, 3, 4, 5, 6. So this one is 0. The formula charge of this atom right here is going to be 0. And this one is 6 minus 1, 2, 3, 4, 5, 6, 7. So this one going to be -1, and this one is the same, so it's going to be -1. For the carbon is have 4 minus 4, so the carbon have formula charge of 0. And I'm going to state the delta notation for this molecule. Okay, no, so the bond between carbon and oxygen is going to be polar covalent bond, but the overall polarity of this molecule is going to be non-polar. Okay, so I'm going to draw the delta notation because oxygen has more electron negativity, so it's going to have the negative sign, delta notation, and carbon going to have the positive sign. Right here. Okay.